All right, guys, we're going to continue our exploration of inverse functions today. The last set of notes we talked about linear functions and how to work with those. Those are a little bit easier to work with and solve, but the process throughout these is the same as before. Our goal for inverse functions is to first make sure the x and y values get switched, and then solve for y. So pause the video and see if you can try these two review problems. And then check the answers with me after you're finished, and we'll go over them if you have any questions. Okay, so here's the solution for the first review. First, you want to replace the y with f of x, or vice versa. And then you want to switch the x and y values. Then you want to solve for y. So in this case, I added 1 to both sides, and I divided by -3. And I write the notation f inverse x with a little -1 symbol, x plus 1 over -3. Or you might see it like this, where all the signs are switched, and that keeps the negative out of the denominator. So either one of those is acceptable. Okay, pause the video for part B. Try that one on your own. Unpause, and then you can check the answer. Okay, same situation in this problem. We are wanting to call that y. We want to switch the x and the y value, and then we want to solve for y. So we are going to multiply the 2 up with the x and subtract the 3. And since the y doesn't have a coefficient, that's going to be your final answer, 2x minus 3. We'll write the inverse notation, g inverse x, with that -1 there. So now that we've reviewed those linear, let's talk about how to do that with nonlinear stuff. You're going to see problems that have square roots, cubes, squares, and maybe other things down the line. But right now, let's focus on these three. In order to do inverse function, what we want to do first is the same operation as before. We want to call that y. I'm going to go ahead and just call all of these y. Our next step is to do the same. We want to switch x and y. So I'm going to swap the x and the y's for all of them. So let's just rewrite all of these. This is going to become x equals the square root of 3y minus 4. This one's going to become x equals y cubed minus 10. And this one's going to become x equals y squared plus 5 over 2. So now we're going to solve all of these for y. So starting with the first one, we want to undo the square. So we have this 3y minus 4 hanging out inside the square root, but that can't go anywhere until we get rid of this radical symbol. So to undo a square root, we are going to square both sides. So square both sides. The square and the square root cancel out. And so you're going to be left with the stuff I circled. So this is going to become x squared equals 3y minus 4. Next step, we're going to add the 4 to both sides. So this will be x squared plus 4. Remember, these are not like terms. So x squared plus 4 equals 3y. And then finally, we want to divide both sides by 3. So your answer before we write the notation is going to be y equals x squared plus 4 all over 3. You also want to write that as g, since that's g of x, g inverse x equals x squared plus 4 over 3. Okay, part B. In this case, our cube is only limited to the y, so we have this minus 10 that we want to add to both sides first. That'll be x plus 10 equals y cubed. And the inverse operation for cube is a cube root, just like the inverse operation for a square is a square root. So we're going to take the cube root of both sides. that cube root will cancel out with the cube, and you'll be left with y. So you have the cube root of x plus 10 equals y. These cancel out. So our final answer will be f inverse x of the cube root of x plus 10. Lastly, we have x squared plus 5 over 2, or y squared plus 5 over 2. So in this problem here, we want to undo the fraction. So we'll multiply both sides by 2. Cancel those 2's out. That's going to leave us with 2x equals y squared plus 5. Next, we're going to subtract the 5 from both sides. That's 2x minus 5 equals y squared. And last, we want to undo the square, so we're going to square root. Let me rewrite this up here. It's going to be 2x minus 5 equals y squared. When we square root, because a square can only be positive, when we square root, you know, a negative squared is a positive and a positive squared is a positive. So we want to be careful and write that as a plus or minus when we get rid of that radical sign. Not just plus, not just minus, but plus or minus anytime you square root. So it'll be plus or minus the square root of 2x minus 5. Notice that it's going over the whole expression equals y. So our final answer will be h inverse x equals plus or minus the square root of 2x minus 5. You don't need a plus or minus with the cube root because you can cube a negative but not positive. So, but you can cube root a negative, but you can't cube square root a negative. So you have to clarify that. And I guess that I did kind of a horrible job of explaining that. But basically, if you square root 9 in your calculator, it's only going to give you 3. However, we know that 3 squared is equal to 9 and negative 3 squared is equal to 9. So the square root of 9 really is a plus or minus 3, a positive 3 or a negative 3. But with cube roots, it's not the same. You know, cube root of 27 is 3. Cube root of negative 27 is negative 3. So that sign is what it is on those, but not for the square roots. Okay, so what you want to try to do are on a separate sheet of paper in, after your notes, work out problems 1 through 6. And then you can check your solutions with me, with a teacher or somebody. I'm not going to post them on this video, but if you work these problems out, the solutions will be available for you. Thanks for watching.